Sorry about that, I'm back. So if you saw the end of the last video, you saw the set working directory command crash. Apparently you can't step through that like I was. So what I did was I ran the whole dang thing and then just set a breakpoint down here. So now I've got more variables, I've got more data. So Control-Shift-S again. This time, because I moved my breakpoint down here, I'm stopping on graphics.off, where I've got a couple plots. This is what we're going to end up making in this example. So I step into that, hit next, graphics.off, cleared my plots. I don't even have my little blue bars anymore, or arrows anymore. And now I want to clear my console. Means get rid of all this stuff down here. Next. Okay. So just a demonstration of running from source with Control-Shift-S, how to use a breakpoint, how to step into things. So I'm going to stop this now. And what I'm going to do now is, you saw that I just plotted some sine waves in different colors. And that's pretty much all we're doing. So the first thing I'm going to do is I'm going to make a variable called myColors. In this very basic example, anytime I create a variable that's a variable that I'm making, it's going to be prefixed with my. Anything that isn't prefixed with my means that this is some kind of system function that belongs to R. So the reason I need to make an empty vector is a vector, you can call them vectors, you can call them matrices, you can call them arrays. The concept is that an array or a matrix is kind of like an Excel sheet. You have rows and columns that are separated or picked out by ID numbers. So you have like a row number and a column number. And then, or in Excel, you would have the column names and the row numbers. So if you go to cell E5, well, that's a bad example. If you go to cell C5, C Charlie, that's the third column in the fifth row. Same kind of thing exists with matrices. I could have just, if I had a matrix that was that same dimensions, I could have said I want to go to column 3, row 5. A vector is just a one-dimensional matrix. So instead of being a whole Excel spreadsheet, it's just column A, or it's just row 1. So we're going to pretend that it's just column A. And when I create this variable, myColors, what I'm doing here is I'm creating an empty vector. I'm not putting anything into it. So I'm going to do the bad thing, and I'm going to hit Control-Enter just to run the single line as a demonstration. And you can see I created a new variable named myColors, and it's empty. Now what I'm going to do is, because I have this variable and it knows that it's going to be some kind of an array, I'm going to use the phrases array, matrix, and vector more or less interchangeably throughout all this, because array and matrix are the same dang thing, just depends who you're talking to, what programming language you're working in. They're the same thing. And a vector is just a 1D, a one-dimensional array. So, yeah, I'm going to screw that one up a lot. So what I'm going to do is that, so think of an Excel sheet of first row is going to have a value of red. Second row is going to have a value of blue. Third row is going to have a value of green. Fourth row is going to have a value of yellow. So Control-Shift-S to run there. And I'm going to step through one line at a time. So I've got my empty array here. Run the first one, red. Now you see that it expanded and got this CHR 1, 2. What this means is this 1 to 2 is the size of this thing. That means it starts at entry 1 and goes to entry 2. CHR is telling me what type of stuff is in here. It's telling me it's characters as opposed to numbers, or as opposed to booleans, which are true-false variables. I'm going to add one more. You can see it expands this to 1 to 3 now. And I can keep adding to this as I go. And then let's say I wanted to read one of these back. Let's do this in the console. Let's say I wanted to know what value was in myColors. Whoops. I can type that in and it'll tell me the value in entry number 3 is green. Now, that's all well and good of, okay, I can type that stuff in, but that's kind of boring in terms of programming stuff of we want a computer to do a whole bunch of automated things for us. So what I'm going to do is right here is I'm going to create a new variable called mySelection. And if you're following along with your own stuff, as I go through this example, go ahead and pause this video and change the values of my selection just to see how these next couple lines work. So what I want to do is I want to type in a number here and have it automatically look up the value for that number. So Control-Shift-S. Next, 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 next. My selection's 2. Now, what I want it to do is I want it to display stuff down here. So what I'm going to do is I'm going to stop this. I'm going to take away this top breakpoint. And I'm going to Control-Shift-S. And what you're going to see is that nothing got spit out when I ran to here. If I copy and paste this to the console, it's going to give me the value of my colors in my selection, which is 2, which says blue, because that's the second entry. But it didn't display it down here. Why not? This is one of the quirks of R of when you're doing this execute from source thing with Control-Shift-S. You have to use this cat command. Cat stands for concatenate, which means take 2 chunks of characters and put them together. And so to get this to display, I have to run this line cat, and now it would have shown that down there. Some of this stuff is a little bit quirky when you're single stepping through, especially with the display stuff, so I'm just going to move my breakpoint down here. You saw the first time that my colors doesn't show anything. Here, what you see is the word blue, and then all the debugger information. All the stuff of called from, eval expression, what this is when we stop on one of these breakpoints, that's stuff that's R's way of telling us, I stopped in the middle of something, and here's where I exited and came back to the console, and now I'm waiting for you, human. So it showed us the word blue up here. Okay, so the point being that we can use another variable to go through these vectors and give us different values. So like, let's say I stopped, hit stop, I changed it to number 3, Control-Shift-S. Here, up at the top, you get green, because that's my third entry. All right, so now the next thing we're going to do is I'm going to stop, going to move my breakpoint, and what I want to do now is I'm going to spit out some sentences that say, I'm just going to say A, B, C, D, kind of as a reference, and I'm going to say the selected color is my colors of my selection. So in our case, since we're still on 3, it's all going to be green. And we're going to run this. So what we get is we get green from up here, from line 39. We get the letter A, and these are why I put these breakpoints in. The selected color is green. B, the selected color is green. C, the selected color is green. Just like these. Why the heck does all this go onto one big line? The reason is that we need a character called newline, which is \n. Anytime we do this \n character anywhere in a concatenate or a paste command, we'll talk about paste later. Anytime we do that in a concatenate command or cat command, that means put us on a new line. So what I'm going to do is I'm going to stop it again. And now, oops, up here I don't end anything in /ns. Here I end everything in /n. If we look at this concatenate command, one thing I should have stopped and explained. What I'm doing here, if we look at this first line, is I'm literally saying take, because I have double quotes here, that's a bunch of characters. I'm saying take the text, A, the selected color is, comma, concatenate the next thing means sticking on the end, which is the lookup value for my colors. And then I'm separating it with nothing. We'll see this a little bit clearer down here when I get them all on a separate line. But the idea being that you get a choice of when you put these multiple things together, what separates them. So like if for example, I wanted to output a CSV file of data for some reason, I'd want to just use a comma as a separator to separate all the different things. It's a style thing where, because of the way that I program, most of the languages I work in, the default is no separation like this, and that's just the way my mind works. So I'm going to put that in a lot. The default for R is to use a space for a separator. But I've shown you a whole bunch of things at once, and then this is a demonstration that we can use anything we want as a separator. Because kitty cat, well, we're doing cat statements, so kitty cat. Let me run this whole thing down to line 55. So Control-Shift-F as always. Okay, scroll back up. So we got a bunch of stuff that got spit out. We got the original stuff up to line 45. That's all blurbed together on one line because I didn't have the new line characters. On line 49, we start getting the new line characters, and now we can more easily see what I did. So that's why I have E, F, G, and H, E, F, G, and H. Because I have all these new line characters, they're all on their own separate line. So if we look at lines F and G, because you'll see that if we count characters, I've got 2 spaces between is and green in both of these. That's the separator value. I already had 1 space because that was part of my existing string. And then I told it put in an additional space between each thing it sticks together. So it did that. If I omit that separator value, that explicitly means to R, use the default value, which is put in a space. So that's why F and G are exactly the same, is because the default is what I put into G. Now, just for the demonstration of, we can see here where I put in kitty cat, green kitty cat, because it put in my separator between these 2 values and my end of line value. This is one of the reasons why I personally tend to like working with a separator of nothing, and I'll put in all the spaces and commas and everything else I need myself. It's a style thing. Do what works for you. There are cases where I'll switch from one to another, depending on what I'm doing. But this is just a demonstration of this is how I write stuff to the console. Now you might be asking, well, why do we want to put stuff to the console on our own? Because, well, we've got R, and R is going to be spitting out all this data for us. Okay, yeah, that's true. But what you may want to do is, let's say you're running a whole lot of data. This is an example we're going to do at some point later. Let's say you want to make a log file that has the results of, let's say you ran some ANOVAs. You may want to have a log file that has all your results, and you can cleanly open it up in Excel and look at it instead of trying to stare at it in the console. There's also some, well, I'm not going to talk about that now. So you may want to format things that are going into that log file. You're going to use the same cat statement. This concept of taking a couple things like this and then using the separator value is also going to become useful when we start doing plots. Because what we're going to do is we're going to use the same kind of structure of text with variables with a separator to do things like put titles onto our plots for us automatically. Because what we're eventually going to do is, instead of trying to figure out what's in our data sets, we're just going to keep asking R to look that stuff up for us and automatically put that on our plot titles. So this concept of strings and variables and separators is going to become relevant for more stuff in the future. All right. So now what I'm going to do is I'm going to hit stop so we can get rid of that highlighter. I'm going to demonstrate an if statement. The purpose of an if statement is, what we want to do is we want to see, we want to read some variable, and if it's true, we're going to do some other thing. So in this case, I said if my selection, which if you remember above, that's a variable I made up that said basically just the ID number for which of my colors are we going to read. If it's equal to 1, this double equals it's part of programming syntax. Double equals meaning that single equals means we're assigning a value to something. So like when I said my selection equals 3, I am assigning the value of 3 to the variable my selection. Here, I'm using the double equals. I'm asking R to check my selection equals 1. So that's either true or false. My selection equals 1? No, it is not equal to 1. It's equal to 3. So it's not going to run this stuff. Go to the next one. If my selection equals 2, nope, so it's not going to do this stuff. If my selection equals 3, yes. So it's going to spit out a line that says my colors of my selection. So again, we're looking up out of that array. Is a bad color, new line, no separator. So we're going to run to this breakpoint. Control-Shift-S again. And what we're going to see as I go through line by line is that it's got this whole chunk highlighted. As it's paused here, it's deciding it hasn't figured out if it's going to go into this if statement and do the action yet or not. I'll hit next. It goes to the next one. Again, it highlights the whole dang thing. Now we know that this one is going to go inside this time because my selection is 3. So I'll hit next. And now you can see that the highlighting changed. It jumped into the if statement. And now it's going to output the line, green is a bad color, end of line. Green is a bad color. And I don't know why I picked these. I just wanted some different text because apparently whatever this is not a color. So that's just a concept of how does an if statement work. Now, the reason that we might use an if statement is this is pretty boring because this is all stuff I had to type in by hand. What I may want to do is that, let's say I'm going to be running an ANOVA on my data. There's limitations like if you only have, let's say you have some data sets that are a little bit screwed up or you've got some things that are mixed and matched. If you only have one category for an ANOVA, that'll crash R. Everything to run an ANOVA, you have to have your continuous and your categorical variables. If you only have one categorical variable, there's nothing to compare against because you're comparing category, the value of one category against the value of another category. So we may do things like check to see, do we have at least 2 categories? If we do, cool, we run the ANOVA. If we don't, then we don't run the ANOVA because R is going to fault because it can't run that. That's the kind of stuff we would use if statements for in a full program. Again, this is just little demonstrations. The other thing you may use an if statement for is, let's say you're going to be checking your data. This will be an example that I'll show you later in some different contexts when we start bringing data in. But let's say that you did some kind of test where you know that you worked on 4 species of trees. Well, after you read in all the data, you can ask R how many species of trees were in this data set. And you can put in a check in your program right in the header before you start running the real stats to say, okay, well, if R is telling me that I have some value other than 4 species of trees, then that means my data is screwed up and I got to go look at something. But let's go ahead and stop before we go all the way into things. The other reason to do things like that is R is case sensitive. So let's say you had typed in elm and elm as 2 different species of trees. R is going to treat that as 2 different ones. So instead of having 1 species named elm, you're going to have 2 species named elm. It's not going to put those together automatically. This would be another reason to use a check structure like this. And that's almost a literal copy of a different example I have that we'll do later. But this is why we would use if statements. Now, we're going to stop this again just so it stops highlighting. Now, we saw with this if statement, this was kind of verbose. There's a lot of type in here. I have to open up an if statement, do the next thing, do the next thing, do the next thing. What I prefer to do is do what's called an if-else. Actually, this is an if-else statement. What this does is each one of these things is independent of each other. If I put in a carriage return between each line, no, I'm not going to bother doing that. But the concept being that if you look at the parens, if you select the parens, it'll show you the other one, or sorry, curly brace. The same thing with any of the parens and square brackets. These are all independent things. So if I had written my logic poorly here, it would be possible for me to execute 2, 3, 4, all these things, or none of them. That's why I like this if-else-if statement. Because what this is going to do is now, because I have this else if stuff going on here, what this is going to do is they're now kind of linked together. So what this says, it is if my selection equals 1, let's just pretend it does, it's going to do this stuff in the first set of curly braces. Then what it's going to do, because everything else is else something, it's going to exit out to the bottom of this. It's not even going to look at the rest of these. It's not going to evaluate them, which can be good because then I can write some logic is, well, I'm going to check this one thing, and if it's this one thing, okay, cool, then I do this, and then I don't have to check anything else. Great. Let's say, for example, we've got my example of, we've got my selection equals 3. What this is going to do when we run it is it's going to say if my selection equals 1, nope. Else if my selection equals 2, nope, don't do this. Else if my selection equals 3, yep, it's going to run this line because this is the one that finally hit true. And then it's going to exit out to the bottom of this. Now let's say I'm going to go ahead and change our number to 5. Well, we're going to run that with 3 first, just to show you. Change my breakpoints. Control-Shift-S. Okay. You can see here that when I mouse over, I get F10 is my next command, so I'm going to be doing that a lot instead of clicking because I don't like my mouse. So I'm going to come up here. I'm going to F10 it. And now it's showing me the line that it's using. So it's going to run that single line. It spit out my line. Green is a bad color for case 3 like we had. Yep. And it didn't even try to look at this one, which is good. Now, the reason we have this final else statement is that let's say that I'm only expecting values between 1 and 4. This is well, it's not kind of an error handler. This is an error handler. So let's say I had punched in a number 5 for my selection, and I run that again. We're going to F10 this a couple times. What it does is that is my selection is 5 equal to 1? Nope. Is 5 equal to 2? Nope. 5 equal to 3? Nope. 5 equal to 4? Nope. So this final else statement gets executed now because it got down here and it hadn't exited yet. It hadn't hit one of these other ones to finish, complete a condition, and go on to the next one. So this is a way of saying, okay, well, we didn't select a color, and we'll get that as a line output to the console. Again, if we're going back to the concept of we have element of species and we have the wrong number of species, we want to stop and clean that up and do something else before we go ahead and run all the rest of the data. Otherwise, you're going to start getting data that looks weird and it's going to be confusing and you're not going to know what's going on. And if you just stopped to put in a quick little check like this, then you'd have fewer hassles. So I'm going to stop execution again, clear my breakpoint. Okay. Now this is what's called a for loop. The way that we would pronounce this is we say for my, whoops, sorry about the mouse over, for my counter. So again, I made a new variable named my counter and I made it up on this line. So I'm going to say for my counter in 1 to 4. What it's going to do is it's going to run this chunk of stuff 4 times. It's going to run it from 1, 2, 3, 4. And every time it runs this loop, it's automatically going to add 1 to my counter. Because the default value, we could put another syntax in here that would say what we're incrementing it by, which is creatively by. But we're going to not talk about that for the moment. because what it's going to do is it's going to increment this for us each time, and this is going to spit out a statement with all the colors in it. Now, for an example like this is just kind of silly, but where this becomes more useful is that we're eventually going to start putting these together in bigger structures. And in general, we don't program a lot of things like how many species of tree do we have. We're just going to start asking R, how many species are there? How many treatments did you do? And the reason that this becomes incredibly powerful very quickly when we start doing the heavier structures is because, let's say we're doing a test where we grew 10 trees of 3 different species of trees. So we're supposed to have 30 trees. And then we're doing our experiments, and it's supposed to be a 20-day experiment. And on day 14, the maintenance guy backed his truck into one of our trees, and now we're down to 29. If we use these kind of structures, what we can end up doing is that for days 1 through 6 before the truck, whatever day the guy ran the truck into the tree, we can still do all of our sampling based on 30 trees. And then, and do all of our math based on 30 trees. And then, as soon as we hit day 7 or whatever, when the maintenance guy hit it with the truck, now we can keep running the same analysis with 29 trees without changing a line of code, because we're just going to keep asking R, how many of this do I have? How many of that do I have? How many of this do I have? We'll get into that in a completely different set of videos, but that's where we're going with this. So for now, what we're going to do is we're going to set a breakpoint here and step through this. So Control-Shift-F again. So stops on my breakpoint. I'm going to F10 it. And we're going to we see that my counter doesn't exist yet. We don't have a value for it. As soon as I enter this loop, I get a value of my counter. The L is a special type of notation, meaning it's a type of integer called a long, which you can just basically ignore and treat it as it's a number whenever you see an L like that. So now we're going to spit out a line that says the current color is, so my colors, which is the vector we had to start with, what is going to be in index 1. It's going to be red. So we F10 it. It says the current color is red. Shows right here. Let me clean that up. It's irritating me. F10 it. We can see that my counter incremented to current color is blue. I hit F10 a couple times there real quick, which is why it's already showing 3. I did more than one line at a time. So current color is green. And so what we get is it goes through the whole set of the array. It says the current color is red, the current color is blue, current color is green. And it's updating this counter for us automatically. You didn't see me add anything to this counter. That's part of a for loop, is it says just go do the next thing. Now that we've seen that run once, there's a little bit of a white lie that I told you in here. When I said when it's doing this from 1 to 4, what this is literally doing is this syntax here says make a list of things. A list in R is a very, very special type. It's not a very special type. A list is a specific type of variable. And it's just a container of stuff. It's a lot like an array, but it's got a few special properties. Think of it just as an array or as a vector. It's for all you care about, it's basically the same thing. But this literally means make me a list of things 1 to 4 by 1. So the list is 1, 2, 3, 4. And give me the stuff out. Later on, we're going to use different things for this list here. That's probably a tangent I maybe shouldn't have gotten on now, but well, whatever, I did it and we're done. So now, the next thing we're going to do is, if you remember at the top of the program, I ran a command that said remove list equals ls to clear out my workspace. Hey, list again. List has some special properties. Speaking of, don't use list as a variable name. That's a bad one because it's syntax for R. So now what I want to do is, in a little example like this, it's not a big deal, but when we get into bigger examples where there's more data, now that I've finished doing this thing, I don't need the variables for my counter anymore. I also don't need my selection anymore. So what I want to do is I want to clean these up and just get them out of here for a couple reasons. One reason is that it cleans up my workspace, so there's less stuff for me to see and I'm staring at fewer things and it's not cluttering my screen. The other reason is that it helps me pick up syntax errors. So, for example, if I do some copy and paste with code, and I copy this line of code, let's say I copied this line of code that had my selection stuff in it, and I thought I was supposed to be done with that, and I copy and paste that and put it down here on line 90 something, it's going to bomb out because it can't read my selection anymore. That's a good thing. Sometimes you want your code to crash because we're done with my selection. What the heck is that code doing down there? Oh yeah, I was hitting copy and paste and I got distracted and I put something on the wrong line where it wasn't supposed to be. So in general, you're going to see me do this a lot in all the templates of just clean stuff up. We're not going to run that as a discrete line. I'm just going to run to here. So, and as you can see, instead of having 3 variables, I threw out the 2 that I said I didn't want. Stop that again. Now, what I want to do here is, if you remember the beginning of this video, I had some sine waves in different colors. What I need to do is, I'm just going to create an array of, or a vector of x values to plot against. So I want to have a whole bunch of values of x, which is going to be x-axis of my plot. I'm going to start at 0, starting from 0, going to 9, and I'm going to increment these by 0.001. We'll copy and paste this into the console so I can show you. So if you look at that, I get a value at 0, 0.01, 0.02, 0.03, 0.04, so on, so on, so on. I didn't have to do these by hand, it did them for me automatically. You can also see that I have 900 points. That would have been way too much for me to type in by hand. This is not a particularly practical thing for a lot of applications, but it'll work for this example. So now what I'm going to do is I made my variable my y, or my x. Now I need to make up some y values. So this is going to be what's going to go on the plot. My y equals sine of my x. Now this is one of those really cool things of working with vectors and arrays, because we have 901 entries for x. I don't want to have to calculate 901 individual entries for the y value. I just want to calculate the sine of y once. And because I'm doing a sine operation on this vector, if I run that, my y equals sine my x, it does the operation on the whole vector. So it took the sine of each individual value of x, which we don't really see here because under small numbers, the sine of a value is the input value. So it's just rounding it off. But we'll Control-Shift-S this because we're going to plot this next. So run that, calculate my sines, and then I'm going to plot my y tilde relative to my x. So instead of having to do something where I put this whole dang thing in a loop, I was able to operate on that entire vector. Now, one of the things that this is going to become more relevant for is, let's say we have some data that we read in, and because we were doing whatever, when we made our measurements, we made all of our measurements in centimeters because whatever reason, and now we've got this in a big data frame in R. And now what I want to do is I want to convert all that to millimeters. I can do the same thing where I can divide an entire column of a data frame in the same way by 10 to convert from centimeters to millimeters. The thing to catch here is that I'm doing a operation on the entire vector, not just a single entry. And then we're going to get rid of this because we're done with that variable. So now what we're going to do is we're going to do the last thing in this demo. We're going to plot all this in a loop and add a title. Remember when I said part of the fun of doing that cat stuff and getting used to the structure of variables with some text and the separator is we're going to use that for plotting. We're going to do that down here. So we're going to again do for my counter. We don't have my counter anymore. We removed that. We're going to create a new one named my counter between 1 and 4. This time we're going to do my y is going to be the sine of my x times my counter. The reason I'm doing this is so that we get, instead of getting the same sine wave 4 times in a row, I'm going to get 4 different sine waves because I'm changing the frequency and period. Then I'm going to plot. Okay, we're going to do a bunch of things in one line here. So here, every time we run this loop, I come up with a new vector of my y. So I'm going to get new values each time. I'm going to plot my y relative to my x. Col is short for colors. So the color, if we look at my colors, it's going to look up my counter. You saw when we did up here, we had the for loop where it said the current color is red, blue, green, yellow. When I ran this loop, instead of just spitting that out to the console, which is boring, what I'm going to just do is say the color for each plot. I'm going to change this to look it up out of this array by number. We're going to step through this slowly. Main is the syntax for the main title. Paste is kind of like cat, but a little bit different. Paste is meaning take, just like cat, it takes a bunch of strings and variables and puts them together. But paste doesn't necessarily, or paste, not necessarily, paste does not put anything to the console. Cat puts stuff down to the console. Paste doesn't. It just puts it together. So what it's going to do is, just like we're playing around with cat, we're going to take this and we're going to turn this into the title. So we're going to F10 this and step through it. So again, the whole thing gets highlighted. On the first line, we can see that my counter is 1. So my y is going to be sine of my x times counter. So it calculates y for us. Cool. We're going to plot my y relative to my x. The color is going to be my colors of 1, because my counter is 1. And then we're going to spit out a title that says the current color is my colors of 1, which is going to be red. And we'll hit that. Here we go. Just like I promised. The current color is red. Came from this line here. I set the color red here. And then the sys.sleep. The reason that this is in here is that this is a weird, quirky thing that R does. If we're running this thing at full speed and not stepping through it, R is basically just going to lose some. It's going to lose some of the plots because R is quirky sometimes. So like right now, I can go back and forth between my old plot and my current plot. Life is cool. If I was running this at full speed and not stepping through it with F10 and the breakpoints, I wouldn't be able to do that. Stuff would be getting lost. So let's run the next iteration. Hit F10. My counter is now 2. Now we can see that my y doesn't match my x anymore. I changed some stuff. We're getting some different numbers. Now we're going to do color equal my colors of 2, which is going to be blue. I'm going to spit out a header that says current color is blue. And as you can see, I changed the period. We carry on. Same thing for green. Same thing for yellow. Yellow is pretty hideous on this white background, but we carry on. I'm going to clear out my y, and the program's done. So we've done all that stuff. Now, we've had a lot of junk going on down in this console here, where there's all these debugs and this and that and browse and whatever. That's awful to look at. And that's because we've been stepping through it in the single block mode with the breakpoints. So I'm going to scroll through and I'm going to clear all my breakpoints. I think I got them so far. Again, that's just clicking in this left column. And now I'm going to Control Shift S. And what you can see, oops, let me go back to this first example. I'm going to change my selection back to 3 so we get a real color. So this ran the whole dang thing for us at once. Control Shift S. We get, if you remember here, we got the spit out my color based on this first diagnostic. We get my cat ABCD example where it's all mushed together on one line. We get the EFGH examples where they're now separated decently. And some are separated by kitty cats. We get the 2 different if statement examples where I did the one where it's just if. Then I get the output of the if else. That's these 2 lines. That's why it's repeated. One is the if and if else. We get the example of my for loop here where I spit out the current color is green. And we get all 5 plots. Remember when I said we needed that sys.sleep to make it prevent R from doing weird things? This is the weird thing. Because I did this plot here without putting that sleep command. Sys.sleep is a fancy way of saying pause. It's in seconds, so this is a 0.1 second pause. Because I didn't put that in here, when we run this at full speed, this is just a quirk of R that I can't explain, and the only way around it is just putting these little pauses. So I hope this video was informative, and we'll get into more stuff in future videos.